Good to see you, John. How you
Good to
doing?
see you.
Thanks for doing this. I appreciate it. So, I hear you've solved the password problem.
Close.
Close. So
Close.
tell me what you guys have done around identity proofing and based on behavioral biometrics. Correct?
Yeah, of course. The password problem is prevalent in healthcare because clinicians often don't have the use of their fingers when they're performing, clinical functions. Passwords and primary factor authentication are prevalent in the use of things like narcotic distribution. There's multi-factor challenges for so many things that we do. It's just not always convenient. And strong passwords, 16-character passwords, are laborious. They're good, they're strong security-wise, but they take a while to type in, they take a long time to memorize, and even though we have tricks like passphrases and song lyrics and poems and whatever, they're still a burden. And so our charge is really to just get rid of as much of them as we can, but replace it with a stronger system, one based on identity proofing that is as transparent as possible to the end users. And so we do that through data that we already have, things that already exist in our SIM tools and our SOAR tools and our clinical databases and access control logs and evidence logs. And the biggest factor, I think, for us is what we call behavioral biometrics. Some people say continuous authentication. I think generally those two intersect completely, maybe not entirely. But behavioral biometrics is just what you're doing, your behavior. So it's when you type on a keyboard, you move your mouse, you use certain applications at certain times of the day, you visit the same applications in the same way, you type the same thing into an email. You can even get into areas around contextual patterns and grammar of how you talk to people. So we focus mostly today on our endpoints with keyboard and mouse movement to try to identify who you are. And after about a 2-week training period that's completely transparent to the users, once we have a good data set, it takes us about 3 seconds to identify you with this mechanism, meaning that you can walk up to a computer and interact with it. And we know who you are within about 3 seconds of activity. Mouse movement, keyboard movement, whatever it might be. And so in that way, you don't have to type a password in anymore. Then we have backup mechanisms like traditional push notifications and MFA on mobile devices when it doesn't work, but it's still passwordless. And so about 30% of our population, our non-clinical population, we've eliminated both username and password entry. Next year, we'll be rolling this out to our clinical population. Because it's a transparent, continuous mechanism, we can also use it for refuting identity. Think of a scenario where a nurse is working on a particular patient and entering some things into the patient's chart, and another nurse walks up and says, "Oh, hey, step aside," or go somewhere else, and let me update my patient too. And we'll know about that identity change, that shared session kind of session hijacking risk. We'll know about that in seconds. So we can basically eliminate the risk of shoulder surfing patient records.
Yeah.
My point is that there's a lot of other benefits to this continuous auth behavioral biometric than simply just the passwordless ecosystem. But that's certainly what we're focused on today, is to eliminate that burden from our clinicians.
So you said that this data exists in SIM and SOAR and other sources. So does that mean you're not deploying anything on any agents anywhere, or take me inside that?
The only agent that we really have in this whole setup is the one that's collecting like the mouse and keyboard data on the desktop laptop. There's also a mobile agent that collects telemetry data on mobile devices for a similar function, but that's pretty much it. The rest of the stuff, like you use these certain applications at these certain times, you open these certain applications at these certain times, you communicate in a certain way with certain people at certain times. We have an email partner that tells us about communication patterns for all of our users. So we can detect, like, for instance, when it's not normal that you talk to a certain person, or when it is normal, and we can improve our confidence that you is you on that machine. those are all agentless, and that data is all stored in the SIM tool or in requisite logs, and we just tap into it with our identity manager, and we just check those logs, or maybe we set an attribute when a log pops up or something, but we're basically just using existing data to enrich and enhance our ability to determine that you is you on that machine.
Is there some AI magic involved here to kind of put that data together?
I couldn't get an interview with you without saying that word, of course. But yeah, so on the continuous auth side and on that agent side, absolutely. And that AI helps us continually learn about your behavioral patterns. So some of the pitfalls here you might think of are like, well, I broke my finger playing basketball over the weekend, so I have a different typing pattern. Yeah, that happens, but the model retrains itself based on your behavior. So this is really just stochastic modeling at scale, and looking for those standards of deviation away from your mean of behavior. But we use AI to infer, I shouldn't say we, our partner who developed this agent uses AI to basically continually readjust their model and learn from your behavior, reapply it to the baseline and go, okay, this is the new normal for Michael as we proceed throughout the day. And then there's different factors. You're tired that day. You stayed up watching TikToks all night long, so you come in and or I don't know, maybe your mouse is on the fritz, and although they don't have the little balls in them anymore, but you remember when the ball would get stuck and you're moving that around. And so that stuff happens, and that's what the AI power is of the model.
So what prompted this? Were nurses kind of like sick of typing in the 16-character complicated password?
Yeah. I think we moved to 16-character passwords, minimum 16-character passwords a few years ago, and it wasn't a popular transition because no one likes to remember 16 characters. Now, there was a couple carrots. We took away password reset as an example. You don't ever have to reset your password anymore. NIST kind of promotes that now. So there was a couple carrots, but it's still 16 characters.
Sure.
And then the longer it is, the more time that surgeon has to type it in. And again, they're gloved up, they've got a mask, they've got doohickeys and magnifying thingies, and or if you've seen our Da Vinci robots or the Da Vinci machines, their face is buried in that thing as they manipulate all the arms from the robot. They don't have time to type that password in, and we don't want them sharing their password with the nurse that's at the, sitting there waiting for instruction, or the other physician sitting there waiting for instruction, or the other PA or NP or whoever it is. You don't want to share that password with your peer. That's the counter to everything that we do security-wise. Don't share passwords. Right. So this mechanism, certainly proven on the non-clinical side, eliminates that risk entirely.
And what amount of upfront work has to be done before you kind of set off on this journey? You have to, I imagine, clearly define roles and who gets this, who doesn't, et cetera.
The complexity is not so much in the role assignment, because we want everybody to use it at all times. Okay. The complexity, I think, was in the conditional logic of the engine. So we have an architect and kind of the supporting team behind him that had to create this massive tree of, well, if they're on this type of system and they do have a Kerberos token or a Kerberos ticket, but they don't have a session login and there's no cookie, but yet we have evidence of a duo push after a certain amount. All this conditional logic was all built into this massive tree. That was the hard part. And then identifying all the circumstances. Okay, it's Sally, and she's remote, and she's not on a managed laptop, and she has her corporate phone where our MFA agent is installed, and the agent's not running for the continuous auth. But all these conditional trees or conditional logic created this massively complex tree. That was the hard part. And then getting that right, or making concessions where, in this case, we'd like to do strong two-factor, solid two-factor. Sure. I think the other problem was, because we've kind of upgraded the strength of our authentication process, choosing what factors are primary or risk-based. I kind of have this notional rule of 2 risk factors equals 1 primary. I totally made that up. I don't know if that has any scientific or mathematical relevance, it's probably like crazy.
Yeah.
But it is an expression that we use when calculating this conditional logic to say, okay, accept this, but not this.
Did you have to sell this internally, either to decision makers or to staff? What were the conversations like? How do you make this argument?
The salesmanship of it, it's not really that hard when you tell people like, hey, I'm going to make it so you don't have to type your password in. That part of it is like, who would say no to that? Like less passwords? And it's a stronger authentication topology because we're considering many more factors, not just the behavioral biometrics, but tokens and application patterns and previous histories and tickets and whatnot. So that part of it is easy. The hard part is assuaging fears of Big Brother, because now you have an agent that's recording their behavior either on their phone, which is everybody's personal privacy freak out level 30 is, oh my gosh, you're going to see my pictures and my websites and whatever. No one wants that. But selling that to our population, that was the hard part. The good thing is that the techniques that we're using are completely anonymized. So there's really no direct relationship. Obviously, there is a direct relationship tying their behavior to an end user, but that's it. Like it's not like we're recording PHI. While we're associating it with an identity, we're recording mouse and keyboard. We're not recording the text they type exactly. We're not recording birth or medical record number or anything in those 18 fields that HIPAA gives to us. So I think the biggest hurdle was just now something's watching what I do, right. And am I okay with that? We only put the agent, the partner that we use to do this, we only put that agent on corporate devices. So if we bought a phone or a laptop for you, then the agent will be there. But I think that's well within our right for acceptable use to put that on a corporate managed device. Mm-hmm.
And how are you measuring success? What was kind of like the before and after? That, you have to
That's
show
a great
somebody?
one. We struggle with that. The metrics, because everybody loves pretty pictures and big blue arrows and graphs and such. So we used our SIM tool to just watch the authentications, and so we have a big old pie chart of, for any 24-hour period, how many authentications were truly passwordless using our system, how many of those were passwordless but they fell out and didn't work with the behavioral biometric, and so they backed up to a push notification or a PIN code or something with a traditional MFA agent. And then we have another slice of that pie that's just flat out didn't work and they had to type their password in. And there's all kinds of circumstances. And so basically we started out with a very, I guess, like this is the pie, I don't know. This shade of pie was this size, and it said, only so many passwordless authentications, and that piece of pie has just grown to a little over 30% today on our non-clinical side. To me, that's the primary metric. The better metric, the more qualitative metric, is that the AWS outage just happened very recently, affected this system because some of the components live in the cloud, and we had nasty grams and hate mail and calls. People that are like, why the hell do I have to type in my Duo code all the time? How come it's always prompting me for Duo? I never used to do this. So it's like kind of that, what is it? You're scorned if you do, scorned if you don't model, right? So now we've gotten so good at passwordless that they're complaining when they have to when they have to type their PIN code in. Right, and I'm like, well, it's still passwordless, right? Yeah, but I had to type it in. I never had to do that before. Well, okay, but it's a good problem to have because they've gotten used to it. They've gotten used to that convenience, and it's strong. It's a strong, true two-factor authentication topology that is very hard to refute and refute. So yeah, it's a great system.
So as a last question, was there a model that you followed, or somebody else doing this in another industry or something like that? I guess what I'm asking, how far ahead of the curve are you guys?
I don't think that, in part of the presentation, I don't think that my team's going to hear this and they're probably going to be like, well, thanks a lot, boss. I don't think what we did was like curing cancer. I think what we did is got really, really smart about the data that we already had, and then we added in this new agent, this behavioral biometric agent. That part's new. But the data that we had, we just got, it's like, let's use the tools in front of us to see if we can cobble together a better solution than we're using today. That's the ingenuity. That's the brilliance of the team. That's the brilliance of our architects in building this all out. But I think that a lot of these tools and techniques you'll see in other areas of society. Apple has a partnership with the LA Clippers, so that when you go to a Clippers game, you just use your phone and ding, walk right in. You ever take the subway in New York? Just touch your phone to the reader, right? That's passwordless, right? That authentication exchange that's happening there, that's kind of the same theme. You're touching your phone to a reader instead of keying onto a keyboard, but it's, I don't know that we're such a maverick in so much as we just figured out how to put our Legos together in a really cool new display.
All right, great stuff. Thank you, John.
Yeah, of course, anytime.